For the zip bike study dataset, there are 6 variables. Zip times is a continuous variable. Helmet is a nominal dichotomous variable. Age is a continuous variable. Sex is dichotomous. Safe is an ordinal variable. And whether or not a rider crashed is a dichotomous or nominal variable. Use the code book, the zip bike study code book, to take your variables as they come into JMP and recode the categorical variables so that the levels are meaningful for analysis. If you do not recode them, then you'll constantly be having to go back to the code book to remember what is 0, what is 1, what is 4. So it is worth your time to simply recode them in advance, and then your output in JMP will be more meaningful to you. As a reminder, to recode variables, select the column that you want to recode, go to Columns, go to Recode, and the recode box will come up. Select Formula column, create a new variable name. We'll call this helmet use, because the question is, do you always wear a helmet when you ride your zip bike? You can see here in the code book, a 0 is no, a 1 is yes. So recode this to no. When you press enter, you'll get a question from JMP. We've entered a non-numeric value for a numeric column. Do we want to convert to character? Yes, we do. And then go back and type in yes for the 1 variable and press recode. And you can see here that we now have all of our no's are 0s and our 1s are yeses. Okay, make sure to save your data so that you have it for the next time. I'm going to save this as zip bike study recode so that I know that the variables have been recoded. So continue on with the other 3 variables. So recode sex, recode how safe do you feel riding a zip bike, and crash. You can see now that all of the variables have been recoded. Sex has become sex, male, female. Safe has become safe riding, with the categories of not at all safe, somewhat safe, mostly safe, and completely safe. And crash has become yes, no. It's important because we see that safety is an ordinal variable, that we make sure that we go into columns and column information, and we want to value order, and we want to make sure that not at all safe is our top, completely safe is our bottom, with mostly and somewhat safe. So this is a 1, 2, 3, and 4, and press OK. The other variables are all dichotomous, so it doesn't actually matter. There is no inherent order to those. So the very first thing that you will want to do in your data is do an analyze distribution on all of your variables so that you have a good understanding of what your data looks like. There are 30 observations, so we can see that there's nothing missing in any of this data. But what we do notice here is that we have an issue with age. Our maximum value of age is 366. That's not correct. There's obviously not a 366-year-old bike rider in the city of Birmingham on a rental bike. In this case, this is an error. It's not an outlier. It's not that they're 80 years of age. That's a possible value. This is clearly an error. So we need to go back to our data set and fix that. So we can see here, this is a short, small data set, so 366. In this case, you would generally go ask whoever collected the data if they could check their records, and they would get back to you and say, oh no, that rider is in fact 36 years of age. So make sure to change the age to 36 years of age for row number 7. That way, when you do a distribution of your ages, you will now see that the oldest age is 74 with the youngest age of 19, and that value has been replaced. So you are now ready to do your analysis of the zip bike study. So make sure to go ahead and save this so that you will have it throughout the rest of the example.